Today, we are tackling a question that honestly feels like it's straight out of science fiction. How does an AI actually write computer code? With tools like GitHub Copilot becoming just a normal part of a developer's day, it's easy to think there's some kind of real magic going on, but it's not magic. It's all about patterns. So let's break it down.
And that really gets us to the heart of it, right? This is the central mystery we're unpacking. If the AI doesn't genuinely get logic, if it doesn't know what a function is or what the program is supposed to accomplish, how on earth can it write code that actually runs? Well, the answer is kind of simpler and also way more fascinating than you might think.
To really wrap your head around this, you have to do one thing first. You have to completely change your perspective. We need to stop thinking about code as a set of logical instructions and start seeing it the way the machine sees it, which is, well, just text.
Okay, so here is the big secret. The exact same AI technology that finishes the sentence, "The quick brown fox jumps," is using the very same principle to write code. It's just predicting the next most probable thing, whether that's a word, a parentheses, a comma. It's all based on what came before it. Honestly, just think of it like the autocomplete on your phone, but on an absolutely massive, massive scale.
So this is the most crucial point to get. The AI is not sitting there thinking about your problem and reasoning its way to a solution. No. What it has done is scan billions and billions of lines of code from all over the internet, and it has become an unbelievably powerful pattern-matching machine. It's seen what comes after def, add numbers A, B, literally millions of times. So it just gives you the most common pattern.
And this incredible technology has a name, a large language model, or LLM for short. Groundbreaking research from places like OpenAI showed that if you use deep learning to train a model on a gigantic dataset, like, say, all the public code on GitHub, it gets incredibly good at predicting the next chunk of text or code.
All right, enough theory. Let's make this feel real. We're going to walk through a super simple example to see exactly how this pattern matching plays out in the real world, line by line. So imagine a developer writes this comment. You can think of it as a prompt for the AI. The model sees this and basically asks itself, okay, based on the millions of Python files I've seen, what text usually comes after a comment describing a function? And the most likely pattern, by far, is a function definition that uses variables matching the words in the comment, like first name and last name.
Okay, so what's next? The AI now looks at this new context. It just wrote a line that has the variables first name and last name in it. So what's the most common pattern to see next? Well, it's usually combining them. So it predicts the next line, creating a new variable it calls full name, and then just adds the two inputs together with a space. It's just following the pattern.
And to finish it off, the AI knows that the pattern isn't quite complete yet. A function that creates a new value almost always needs to return that value at the end. See? The AI isn't designing a function here, it's just completing a statistical pattern that it has seen thousands upon thousands of times before.
So how does this cool research project become a tool that you can actually use? Well, the original paper tells the story pretty clearly. OpenAI took one of their big GPT models and trained it specifically on a massive data set of code from GitHub. The result of that experiment was a new model they called Codex. And that is the core technology that powers GitHub Copilot.
So, okay, this tool is obviously incredibly powerful. But, and this is a really big but, because it's just a pattern matcher and not a real thinker, it has some very specific strengths and some very real and very important weaknesses.
The strengths are pretty amazing. You can't deny it. It is blazing fast at writing all that common, repetitive stuff, what we call boilerplate code. It can also help you discover new functions or different ways of doing things. And all of that frees up a developer's brain power to focus on the big picture problems, not just typing everything out.
But what about the weaknesses? To really understand them, we have to go right back to the source, that original research paper that introduced Codex. The scientists behind it created a test called HumanEval to measure how often the AI could write a correct working program just from a description. And the results were pretty humbling.
On its very first try, the model produced a functionally correct solution just 28.8% of the time. That single number, is the key to understanding the reality of this technology.
Let that sink in for a second. When it was faced with a new problem, the AI was wrong more than 70% of the time on its first pass. Now, to be fair, the paper does show that if you let it try again and again, it gets much better.
But this first number tells you everything. This AI is not some infallible coding genius. It's a suggestion engine that is very, very often wrong.
And that 70+% failure rate, it explains all of its weaknesses perfectly. It generates code that looks right because the pattern is familiar, but it can be filled with really sneaky bugs. It has no big picture understanding, so it will happily write a function that works by itself, but completely breaks the logic of your whole application. And because its knowledge is just a snapshot of old public code, it might suggest outdated or even insecure practices, and it would have no idea. Just like the researchers said, its pattern-matching brain just gets totally lost when a problem requires a long chain of real logical reasoning.
So what do we do with a tool that's both this powerful and this flawed? That's the million-dollar question for the entire future of making software.
And here's the answer, I think. AI is not coming to replace programmers. It's becoming a new kind of tool. The absolute best way to think about it is as an AI pair programmer. It's like having a partner sitting next to you, constantly making suggestions, but it's a partner you have to supervise really, really carefully.
I love this analogy because it perfectly captures the new relationship. The human developer is the architect. They understand the goal, they design the system, they make all the critical decisions. The AI is the incredibly fast typist who helps you build it, who sometimes makes mistakes, and ultimately, the human is responsible for checking and validating every single line of code.
And this leaves us with a really fascinating final thought to chew on. As these AI tools get better and better and they take over more of the mechanical act of just typing code, what becomes the core skill of a programmer? The job is changing right under our feet. It's shifting away from just writing code and more towards being an expert editor, a master prompter, and a true system architect. The value isn't just in knowing how to write the code anymore, but in knowing what code needs to be written in the first place. And that, well, that's the biggest change of all.